March 23, 1899, Buffalo, New York. The engineering assessment from European-trained steel executives would never fully capture what they witnessed that spring morning. An American industrialist, relocating an entire $6 million steel operation using methods that defied everything established wisdom said was necessary for profitable steelmaking. Through the mud and construction noise of the Lake Erie shoreline, William Walker Scranton surveyed undeveloped land that seemed impossible to European observers. No proximity to coal mines, no established rail infrastructure, no proven track record of Great Lakes steel production. Yet he envisioned integrated manufacturing that European tradition-bound plants could not match. In European steel mills, companies accepted transportation costs as unchangeable. Raw materials traveled thousands of miles through multiple middlemen, different suppliers, different shipping methods, different profit margins eaten by inefficiency. Most carried operational costs that made long-term survival nearly impossible. The Americans were operating with industrial philosophy the Europeans had never imagined possible. Vertical integration, direct ore shipping, systematic control of every supply chain variable, production methods that reduce costs through engineering rather than just cheaper labor. 800 miles from Pennsylvania coal country, the most decisive industrial revolution in American steelmaking history was revealing itself. Not in superior blast furnaces, not in premium raw materials, but in the systematic coordination that connected every aspect of steel production in ways European steel tradition never imagined possible. William Walker Scranton stood on the Buffalo shoreline that March morning in 1899, watching ice chunks drift across Lake Erie's gray waters. At 55, he had spent 3 decades transforming his father's modest iron works into Pennsylvania's second-largest rail producer. But the mathematics of survival had become brutally clear. The United Mine Workers strikes demanding 10% wage increases weren't just labor disputes, they were death sentences for any steel company trapped in Pennsylvania's anthracite region. Every ton of Minnesota iron ore traveling over 1,000 miles inland to Scranton's furnaces cost more than the finished steel could sell for in an increasingly competitive market. The letter of introduction from John Albright, president of Ontario Power Company, had opened doors that conventional steel wisdom insisted should remain closed. European-trained engineers from Pittsburgh to Philadelphia had scoffed when word leaked of Scranton's reconnaissance mission. Moving a $6 million operation that had anchored the city of Scranton since 1840 was financial suicide, they argued. The Delaware, Lackawanna, and Western Railroad's 60,000 tons of annual rail capacity represented America's industrial backbone. Why abandon proven success for untested theories about Great Lakes shipping advantages? But Scranton saw what his competitors missed. Standing beside Henry Wareham on that Buffalo waterfront, he wasn't calculating traditional transportation costs. He was engineering a completely integrated system. Iron ore boats from Minnesota's Mesabi Range could dock directly at blast furnace stockyards through a 3,300-foot canal. No railroad markup, no storage fees, no delays waiting for rail cars that might be diverted to higher-paying cargo. The Delaware, Lackawanna, and Western Railroad that Scranton's company owned could deliver finished steel products directly to eastern markets without paying competing railroads a cent. Wareham spread engineering drawings across a makeshift table as wind whipped off the lake. The German train manager had supervised every major upgrade since Scranton adopted the Bessemer process in 1876, doubling capacity and quadrupling output. Now he studied Buffalo's topography with the same methodical precision that had made Pennsylvania's operation profitable for 30 years. The undeveloped shoreline in West Seneca offered everything European steel tradition said was impossible: deep water access, unlimited expansion space, and proximity to both Great Lakes iron ore and eastern markets. Within 24 hours, Scranton and Wareham had selected their site. Within 30 days, they had paid $1,095,430.98 for the real estate, more than most steel companies' entire annual revenue. Pittsburgh executives read the news with mixture of disbelief and schadenfreude. Andrew Carnegie himself had written that same year that smaller steel producers like Scranton would inevitably cease to make rails as market consolidation eliminated inefficient operations. Moving an entire steelworks to an unproven location seemed like accelerated corporate suicide. Construction began July 14, 1900, but reality proved more brutal than even the skeptics predicted. Labor shortages plagued every phase as skilled steelworkers refused to relocate from Pennsylvania's established industrial communities to Buffalo's undeveloped lakefront. Material deliveries faced constant delays as suppliers questioned whether the project would survive long enough to pay invoices. Local infrastructure couldn't support the influx of workers, leading to outbreaks of cholera, typhoid, and influenza in hastily constructed housing that West Seneca officials blamed on Scranton's rushed construction timeline. The Scranton Times-Tribune, covering the dismantling of their city's economic foundation, captured the industrial tragedy in stark terms. They deliberately butchered in cold blood a magnificent $6 million plant, destroying machinery that was actually earning for them yearly almost its weight in gold. Equipment that had operated in profitably for decades was junked or sold for scrap, as Scranton systematically stripped Pennsylvania operations to feed Buffalo's construction demands. Financial pressure mounted as construction costs spiraled beyond initial estimates. The company reorganized as Lackawanna Steel Company on February 14, 1902, issuing $60 million in stock just to maintain liquidity. $20 million of that amount went directly to construction expenses, money that produced no immediate revenue, while Pennsylvania operations wound down and Buffalo's blast furnaces remained unfinished. Wall Street analysts predicted bankruptcy before the first ton of steel could be produced. European-trained competitors watched with growing confidence as Scranton's gamble appeared to validate every criticism of American industrial recklessness. Traditional steel wisdom emphasized incremental improvements within proven systems, upgrading existing furnaces, negotiating better coal contracts, optimizing established transportation networks. Scranton's approach of rebuilding an entire integrated operation from scratch violated every principle of conservative engineering management. The first equipment arrived from Scranton in early 1901, massive blast furnace components traveling by rail in pieces that required complete reassembly. Each shipment represented both progress toward Buffalo's opening and further destruction of Pennsylvania's industrial capacity. The company that had employed thousands in Scranton now employed hundreds in construction jobs that offered no guarantee of permanent employment once Buffalo's operations began. December 23, 1902, marked a symbolic victory when the mill received its first shipment of iron ore via Great Lakes transport. Minnesota iron ore that had previously traveled over 1,000 miles by rail now arrived directly at Buffalo's stockyards through the engineered canal system. Transportation costs dropped by more than half compared to Pennsylvania operations, validating at least one element of Scranton's integrated vision. But validation and success remained entirely different achievements. Not a single ton of steel had been produced. The blast furnaces stood cold and untested. The rolling mills awaited their first metal. 79 years later, industrial historians would recognize December 1902 as the moment America's longest-running major steel operation began. But in that winter of uncertainty, William Walker Scranton had only transformed a profitable Pennsylvania steel company into an expensive Buffalo construction project with no guaranteed future. October 20, 1903. The blast furnace roared to life at 6:37 in the morning, marking the official beginning of what would become America's largest steel facility. William Walker Scranton stood in the control room watching molten iron flow from the first successful tap, but his attention focused on the engineering symphony occurring across 1,300 acres of integrated operations. This wasn't simply another steel plant, it was a complete reimagining of how raw materials became finished products. The vertical integration that European critics had dismissed as financially reckless now revealed its operational genius. Minnesota iron ore boats docked at the company's private harbor, unloading directly into stockyard conveyor systems that fed blast furnaces without a single intermediate handler. The Delaware, Lackawanna, and Western Railroad, wholly owned by Lackawanna Steel, delivered coal from company-owned Pennsylvania mines on schedules coordinated with production demands rather than railroad profit margins, no transportation markups, no storage delays, no dependency on outside suppliers who might prioritize other customers during peak demand periods. Henry Wareham supervised the orchestration with Germanic precision, coordinating ore deliveries, coal shipments, and production schedules through a communication system that connected every operational element. Ships arriving Monday morning carried iron ore that became molten iron Tuesday, rolled steel Wednesday, and finished rails Thursday, with Friday shipments to construction projects across the eastern seaboard. The 5-day cycle from raw material to delivered product eliminated inventory costs that plagued competitors forced to stockpile materials through multiple suppliers. Bethlehem Steel's acquisition of Lackawanna Steel in 1922 for $60 million validated Scranton's vision while triggering the next phase of systematic expansion. The Pennsylvania-based company immediately invested $40 million additional dollars in modernizing operations, recognizing that Lackawanna's integrated infrastructure offered competitive advantages worth preserving and expanding. Unlike quarterly profit-driven modern corporations, Bethlehem approached Lackawanna as a multi-decade investment requiring patient capital and long-term strategic thinking. The 1936 completion of the 22-acre, $20 million hot strip mill demonstrated Bethlehem's commitment to technological leadership. The facility stretched nearly half a mile along the lakefront, housing rolling equipment capable of producing steel sheets wider and thinner than any competitor could manufacture. But the mill's true innovation lay in its integration with existing blast furnace operations. Molten steel flowed directly from furnaces to rolling equipment without intermediate cooling and reheating that wasted energy and degraded metal quality. World War I proved the system's capacity under maximum demand. Annual steelmaking reached 1.1 million tons with 15,600 employees operating around-the-clock shifts. The integrated infrastructure absorbed wartime production surges that would have overwhelmed plants dependent on external suppliers. When the federal government needed steel rails for military transportation, Lackawanna delivered finished products within weeks rather than months because every component of the supply chain responded to unified management decisions. The Gray Rolling Mill's 1908 introduction of America's first wide-flange structural sections revolutionized skyscraper construction while demonstrating how vertical integration enabled innovation. Traditional steel companies purchased raw materials from multiple suppliers, limiting their ability to experiment with new alloy combinations or manufacturing processes. Lackawanna's control over iron ore selection, coal chemistry, and blast furnace operations allowed metallurgical experimentation that produced stronger, lighter structural steel specifically designed for high-rise construction. By World War II, Lackawanna had become the world's largest steelmaking operation, employing 20,000 workers across an industrial complex that processed raw materials into finished products more efficiently than any competing facility. The integrated system's wartime performance validated every aspect of Scranton's original vision. Ships docked Monday morning with Minnesota iron ore, and finished steel products for aircraft carriers and tank armor shipped Friday afternoon. No competitor could match this production cycle because no competitor controlled every operational variable. The 1949 through 1952 uranium fuel rod production demonstrated the facility's technical sophistication and security capabilities. Nuclear reactor components required metallurgical precision and handling protocols that only integrated operations could provide. External suppliers couldn't guarantee the quality control or security clearances necessary for atomic energy applications. But Lackawanna's vertical integration enabled specialized production while maintaining operational security throughout the manufacturing process. Basic oxygen furnaces came online in 1964, representing the most significant technological upgrade since the original blast furnace construction. The 100-ton capacity furnaces reduced steelmaking time from hours to minutes while producing higher quality steel with more precise carbon content control. But installation required coordination across the entire integrated system, or preparation, coal handling, transportation infrastructure, and rolling mill operations all needed modification to accommodate the new furnace's faster production cycles. The plant's peak employment of 20,000 workers in 1965 created economies of scale that modern steel facilities cannot replicate. Fixed costs for infrastructure, management, and equipment maintenance spread across massive production volumes, reducing per-ton expenses below levels that smaller operations could achieve. Administrative overhead that might represent 30% of costs in a 300-person facility represented less than 10% when distributed across Lackawanna's workforce. 1973 marked both triumph and warning as the plant produced 23.7 million tons of raw steel while reporting $207 million in net income. Record production validated the integrated system's efficiency, but global competition was introducing variables that vertical integration couldn't control. Foreign steel plants, using government subsidies and cheaper labor, began undercutting American prices despite Lackawanna's operational superiority. The engineering achievement remained undeniable. Iron ore arrived Monday morning at company-owned docks, traveled through company-owned transportation systems, processed in company-owned furnaces using company-owned coal, rolled in company-owned mills, and shipped via company-owned railroads. 70 years after Scranton's Buffalo Gamble, the integrated system operated exactly as originally envisioned, transforming raw materials into finished products through unified management control that eliminated inefficiencies competitors accepted as unavoidable business costs. The 1920s Modernization program revealed the fundamental difference between patient capital and quarterly profit optimization. While competitors focused on immediate returns and dividend payments, Bethlehem Steel committed $40 million to systematic upgrades that wouldn't generate full returns for decades. Engineers redesigned blast furnace operations, expanded rolling mill capacity, and rebuilt transportation infrastructure, with the understanding that steel production required generational thinking rather than annual profit targets. Each improvement built upon Lackawanna's integrated foundation rather than replacing it. The 1924 installation of newer handling equipment increased unloading capacity from 2,000 to 4,000 tons per hour, but the real advantage lay in coordination with existing blast furnace schedules. Ships arrived precisely when furnaces needed raw materials, eliminating storage costs and inventory management that plagued competitors forced to stockpile materials from unreliable suppliers. The 1936 hot strip mill represented more than $20 million in single project investment, but Bethlehem's executives understood that modern steel markets demanded wider, thinner products that traditional rolling equipment couldn't produce. The 22-acre facility required complete redesign of material handling systems, but integration with existing blast furnace operations meant molten steel flowed directly to rolling equipment without energy-wasting intermediate steps that increased production costs and reduced metal quality. World War II production demands tested every aspect of the patient capital philosophy. Government contracts required delivery schedules that would have bankrupted companies dependent on external suppliers. But Lackawanna's integrated operations absorbed wartime surges through systematic capacity utilization. The facility produced armor plate for battleships, structural steel for aircraft carriers, and precision components for military vehicles while maintaining civilian production schedules that kept American infrastructure projects operational. The uranium fuel rod production from 1949 through 1952 demonstrated how decades of integrated operations enabled specialized manufacturing that newer facilities couldn't attempt. Nuclear reactor components required metallurgical precision and security protocols that only established operations with proven quality control could provide. Lackawanna's 46 years of continuous operation had created institutional knowledge and technical capabilities that government contractors couldn't replicate in purpose-built facilities. 1962 brought the new $20 million galvanizing line stretching 1,000 feet along the lakefront. The installation required 18 months of construction and coordination with existing rolling mill operations, but the investment reflected Bethlehem's commitment to technological leadership rather than short-term cost minimization. Competitors could purchase smaller galvanizing equipment for immediate installation, but Lackawanna's scale allowed specialized coating processes that produced superior corrosion resistance for premium market applications. The 1964 basic oxygen furnace installation represented the most significant technological upgrade since the original blast furnace construction. 100-ton capacity furnaces reduce steel making time from 8 hours to 45 minutes, while producing steel with more precise carbon content control. But implementation required systematic modification of the entire integrated operation, or preparation systems, coal handling equipment, molten metal transportation, and rolling mill coordination all needed redesign to accommodate faster production cycles. Peak employment of 20,000 workers in 1965 created cost advantages that modern steel facilities cannot replicate. Administrative overhead, equipment maintenance, and infrastructure costs spread across massive production volumes reduced per-ton expenses below levels achievable in smaller operations. A modern 500-person steel plant might dedicate 15% of its workforce to management and administration, while Lackawanna's scale allowed the same administrative functions to represent less than 5% of total employment. The 1973 $50 million bar mill installation continued the patient capital approach even as global competition intensified. The facility produced specialty steel products for construction and manufacturing applications, but the real strategic value lay in market diversification. Integrated operations could shift production between different steel grades and product types based on demand fluctuations, while competitors specialized in single product lines faced plant closure when market conditions changed. 1981 marked the final major investment with a $10 million galvanizing line improvement that enhanced coating quality and production speed. By this point, foreign competition had fundamentally altered global steel markets, but Bethlehem continued long-term investment strategies that assumed decades of continued operation. The galvanizing upgrade improved product quality for automotive and construction applications, maintaining Lackawanna's technological edge even as subsidized foreign steel undercut American pricing. The patient capital advantage became most apparent during economic downturns when competitors faced bankruptcy, while Lackawanna maintained operations through diversified production capabilities. The 1970s recession forced dozens of smaller steel companies into closure, but integrated operations could shift between different product lines, adjust production schedules, and modify raw material sourcing to maintain profitability during market disruptions. Quality control improvements accumulated over decades of continuous operation created competitive advantages that newer facilities couldn't replicate. Furnace operators with 30 years of experience could adjust blast temperatures and material mixtures based on subtle changes in flame color and furnace sounds that automated systems couldn't detect. Rolling mill technicians understood how seasonal temperature variations affected steel properties and adjusted equipment settings accordingly. This institutional knowledge represented decades of accumulated expertise that competitors couldn't purchase or replicate through equipment upgrades. The integrated system's efficiency peaked during the early 1970s when every operational component functioned at optimal capacity. Iron ore boats arrived on schedules coordinated with blast furnace production cycles. Coal shipments from company-owned Pennsylvania mines delivered precisely the carbon content needed for specific steel grades. Rolling mills operated at maximum throughput, while maintaining quality standards that commanded premium prices in construction and manufacturing markets. Transportation cost advantages remained substantial throughout the expansion period. Competitors paid railroad companies to transport raw materials and finished products, with shipping costs representing 15 to 20% of total production expenses. Lackawanna's ownership of the Delaware, Lackawanna, and Western Railroad eliminated transportation markups while enabling production scheduling that minimized inventory costs and storage requirements. The 1973 production record of 23.7 million tons of raw steel with $207 million in net income represented the culmination of 70 years of patient capital investment and systematic operational improvement. Every upgrade from the 1920s through 1980s had built upon the integrated foundation that William Walker Scranton established in 1899, creating compounding returns that quarterly profit-focused competitors couldn't achieve through short-term optimization strategies. The 1965 import statistics arrived at Bethlehem Steel headquarters like a death certificate for American industrial dominance. More than 10 million tons of foreign steel had entered United States markets for the first time in the nation's history, representing a fundamental shift that Lackawanna's integrated operations couldn't control through engineering efficiency or cost reduction. Japanese and European producers, using government subsidies and newer technology, had achieved production costs that undercut American pricing despite transportation expenses across two oceans. Lackawanna's plant managers watched global competition with growing alarm as foreign steel companies operated under different economic rules. Government-subsidized operations in Japan could sell steel below production costs to gain market share, absorbing losses through national industrial policies rather than corporate profitability requirements. European steel producers benefited from lower labor costs and newer facilities built with post-war reconstruction funding that American companies couldn't access. The integrated system that had provided competitive advantages for 60 years suddenly faced competitors who didn't need to generate profits. Employment began its inexorable decline as orders shifted to lower-priced foreign suppliers. The 20,000 workers of 1965 represented peak employment that would never return, but the reduction occurred gradually as Bethlehem management attempted to maintain operations through productivity improvements and cost-cutting measures. Blast furnace crews that had operated with 15 workers per shift found themselves reduced to 12, then 10, as automation eliminated positions that had required manual operation for decades. By 1977, employment had dropped to 8,500 workers, despite production levels that remained competitive with global standards. The paradox of increasing productivity alongside decreasing employment reflected technological advances that reduced labor requirements while failing to address fundamental cost disadvantages created by subsidized foreign competition. Lackawanna could produce steel more efficiently than ever before, but efficiency couldn't overcome artificially low prices from government-supported overseas producers. The 1978 import surge to 21 million tons demonstrated how global overcapacity had fundamentally altered steel markets. Countries including Japan, South Korea, and several European nations had built steel, production capacity that exceeded domestic demand, creating export pressure that flooded international markets with surplus steel. American producers found themselves competing not just against foreign companies, but against entire national industrial policies designed to maintain employment and industrial capacity regardless of profitability. Quality advantages that had sustained Lackawanna through previous competitive challenges proved insufficient against the scale of foreign subsidization. American construction companies and manufacturers acknowledged that Lackawanna's steel often exceeded specifications and delivered superior performance characteristics, but cost differentials of 20 to 30% made foreign steel financially irresistible for projects focused on lowest bid contracting. Engineering superiority couldn't justify price premiums when budgets demanded cost minimization. The integrated system's strengths became strategic vulnerabilities as global competition intensified. Vertical integration that had eliminated inefficiencies and reduced costs during Lackawanna's expansion now represented massive fixed investments that couldn't be easily modified or abandoned. Competitors using electric arc furnace technology could build new facilities for a fraction of Lackawanna's replacement cost, while focusing on specific market segments rather than comprehensive steel production. Bethlehem Steel's corporate financial performance reflected industry-wide pressures that individual plant efficiency couldn't overcome. Despite record 1981 sales of $7.3 billion, the company reported a catastrophic $1.5 billion loss in 1982 as global overcapacity and subsidized competition eliminated profit margins across all product lines. The integrated operations that had generated consistent profits for 8 decades faced market conditions that made profitability impossible regardless of operational excellence. Plant modernization investments continued, even as financial losses mounted, reflecting management's belief that technological superiority could eventually overcome cost disadvantages from foreign subsidization. The early 1980s brought additional automation equipment and process improvements designed to reduce labor costs and increase productivity, but these investments required capital expenditures that further strained corporate finances during a period of declining revenues and negative cash flow. The psychological impact on Lackawanna's workforce proved as devastating as the economic consequences. Workers who had spent entire careers with the company watched employment levels decline while automation eliminated positions that had provided middle-class incomes for multiple generations. The social fabric of Buffalo's steel-dependent communities began unraveling as families faced unemployment and local businesses lost customers who had supported the regional economy through steel plant wages. Management attempted to maintain operations through union negotiations that reduced wages and benefits in exchange for employment security commitments, but global competitive pressures made such agreements temporary measures rather than permanent solutions. Workers accepted pay cuts and reduced benefits during the late 1970s, but further concessions couldn't bridge the cost gap created by subsidized foreign steel that sold below actual production costs. The final blow came not from operational failures or technological obsolescence, but from corporate financial decisions that reflected industry-wide recognition that American integrated steel production had become economically unsustainable. Bethlehem Steel's board of directors faced bankruptcy unless the company eliminated unprofitable operations immediately, forcing management decisions that prioritized corporate survival over plant preservation or worker employment. June 25, 1982. The announcement arrived at 7:30 in the morning through corporate communications that had been carefully coordinated to minimize advanced speculation. Bethlehem Steel would close Lackawanna and lay off its remaining 10,000 workers within 6 weeks. The decision reflected financial mathematics rather than operational assessment. The plant continued producing high-quality steel efficiently, but global market conditions made profitable operation impossible regardless of productivity improvements or cost reduction efforts. The systematic dismantling began immediately as equipment sales and scrap metal recovery attempted to minimize corporate losses from the facility closure. Blast furnaces that had operated continuously for decades were shut down permanently, their massive infrastructure too specialized for alternative uses and too expensive to relocate. Rolling mills that had produced millions of tons of structural steel for American construction projects stood idle as buyers evaluated equipment for resale to overseas steel producers. October 15, 1982, marked the end of 79 years of continuous steel production. The last heat of molten steel flowed from blast furnaces at 11:47 in the evening, ending the longest operating major steel plant in American history. Workers who had expected to retire from Lackawanna instead watched their careers end abruptly as global economic forces beyond their control eliminated an industrial operation that had defined Buffalo's economy and identity for nearly 8 decades. The electric arc furnace revolution that replaced integrated steel production represented a fundamental philosophical shift from engineering systems to manufacturing businesses. Modern steel plants using electric arc furnaces could begin operations with capital investments of $140 to $200 per ton of annual capacity, compared to over $1,000 for integrated blast furnace operations like Lackawanna. But this apparent cost advantage masked critical dependencies that made long-term survival nearly impossible. Electric arc furnaces melted scrap metal rather than processing raw iron ore, creating complete dependence on scrap supply markets that operators couldn't control. Steel companies that had once owned iron ore mines, coal operations, and transportation systems now found themselves bidding against competitors for recycled metal whose prices fluctuated based on global economic conditions. When construction activity declined, scrap metal became scarce and expensive. When manufacturing activity increased, scrap prices spiked beyond levels that allowed profitable steel production. The 20-year average lifespan of modern steel facilities reflected not just equipment limitations, but fundamental business model vulnerabilities that integrated operations like Lackawanna had avoided. Electric arc furnaces required major rebuilds after 15 years of operation, with complete replacement necessary after 25 to 30 years maximum. Unlike blast furnaces that could operate for decades with periodic maintenance, electric furnaces faced technological obsolescence that required constant capital reinvestment just to maintain existing production capacity. Grid electricity dependence created additional operational risks that integrated steel producers had never faced. Modern plants consume massive amounts of electrical power during peak production periods, making them vulnerable to utility rate increases and grid reliability problems. When electrical costs increased due to fuel price volatility or regulatory changes, steel producers had no alternative energy sources. Lackawanna's coal-fired power generation had provided energy cost stability that modern electric furnace operations couldn't replicate through market-based electricity purchasing. Global overcapacity forced plant closures worldwide as governments shifted industrial policies and trade relationships eliminated previously protected markets. Britain's Scunthorpe Works, operating since 1890, shut down in 2024 after bleeding £700,000 daily, despite modern equipment and skilled workforce. The facility's closure reflected economic reality that operational efficiency couldn't overcome when competitors received government subsidies or accessed cheaper raw materials through different regulatory environments. Trump administration steel tariffs in 2024 demonstrated how modern steel plants remained vulnerable to political decisions beyond their operational control. 25% tariffs eliminated £400 million in annual UK steel exports, forcing European producers to seek alternative markets, while American producers faced retaliation through counter tariffs that restricted their export opportunities. Integrated operations like Lackawanna had served primarily domestic markets, reducing exposure to international trade disputes that modern global steel markets couldn't avoid. The engineering proof of integrated superiority remained mathematically demonstrable despite changed economic conditions. Lackawanna's blast furnace operations had controlled every input variable from Minnesota iron ore composition to Pennsylvania coal chemistry to Great Lakes transportation scheduling. Modern electric arc furnace plants must purchase scrap metal from brokers, buy electricity from utilities, and compete globally with no sustainable cost advantages. They operate as manufacturing businesses rather than engineering systems. Chinese steel production exemplified how modern overcapacity created unsustainable global market conditions. China's steel products averaged 25-year lifespans before becoming scrap metal, creating continuous recycling cycles that flooded global markets with both finished steel and scrap materials. When Chinese construction activity declined, excess steel production sought international markets at prices below production costs, making profitable operation impossible for steel producers in countries without government subsidization. Modern steel plants optimized for quarterly profit targets rather than generational operation created business models fundamentally different from Lackawanna's patient capital approach. Contemporary steel companies face pressure to maximize short-term returns through debt financing and shareholder dividends, preventing the long-term investments in vertical integration that had created Lackawanna's competitive advantages. Equipment purchases focused on fastest payback periods rather than operational longevity or strategic integration. The competitive landscape that destroyed modern steel plants would have been familiar to Lackawanna's original competitors, who had dismissed William Walker Scranton's Buffalo gamble as financial recklessness. Modern steel executives, like their European-trained predecessors in 1899, optimized existing systems rather than reimagining fundamental business models. They accepted transportation costs, raw material price volatility, and energy dependence as unchangeable business conditions rather than engineering problems requiring systematic solutions. Lackawanna's 79 years of continuous operation produced 165 million tons of steel while employing over 20,000 workers at peak production. The facility's integrated operations had survived 2 world wars, multiple economic recessions, and decades of technological change because vertical integration eliminated dependencies that modern plants couldn't avoid. Raw materials arrived Monday morning and finished products shipped Friday afternoon through systems that Scranton's company controlled completely. Modern steel plants averaged 15 to 25 years of operation before closure, consolidation, or major technological replacement. Their dependence on external suppliers for raw materials, energy, and markets created vulnerabilities that operational efficiency couldn't overcome when global economic conditions changed. Unlike Lackawanna's integrated system that had adapted to changing conditions through internal operational adjustments, modern plants faced closure when external market forces made continued operation unprofitable. The American lesson extended beyond steel production to fundamental questions about industrial strategy and national economic policy. Scranton's 1899 vision of vertical integration had created competitive advantages that lasted 8 decades because it eliminated dependencies on external suppliers and market conditions. Contemporary American manufacturing, optimized for global supply chains and quarterly profit maximization, traded engineering permanence for financial efficiency and achieved neither sustainable profitability nor operational longevity. Today, 14 wind turbines occupy the remediated brownfield site, where Lackawanna's blast furnaces once operated continuously for 79 years. The wind turbines represent clean energy technology that addresses environmental concerns, but their expected 20-year operational lifespan reflects modern engineering's acceptance of planned obsolescence rather than generational durability. They symbolize the fundamental shift from building systems that last to building businesses that optimize short-term returns. The numbers validate Scranton's vision with mathematical precision. Lackawanna operated for 79 years, produced 165 million tons of steel, and employed 20,000 workers at peak capacity. Modern steel plants average 20 years maximum operation, depend on global supply chains they cannot control, and remain vulnerable to foreign subsidies that make profitable competition impossible. American Steel had once built the Brooklyn Bridge, the Empire State Building, and supplied 2 world wars because engineers like Scranton built systems for generations rather than quarters.